original triangle that was used in order to create 30, 60, 90, right, special triangle was actually 60, 60, 60 triangle, in which all three sides were exactly the same. Then we cut it into two exact pieces, remember we did it, and then we kind of said, well, you know what, then one of these two newly created triangles, which is a half of the previous one, is going to have a spect of 30, 60, 90, just because of simple geometry. We cut one angle into two, so we had to make it 30, 30. But the sides are nothing, we didn't create new sides, except for this imaginary side, right, this third side, which we call height, h, and then we said, well, because we can call any side any way we want, and we can actually use any measurement we want, because at the end of the day we want to figure out the ratios. We can, the moment we call, let's say, you see, you make a choice, you say, what do I call? Okay, if I call this side to be 1 centimeter, this side, it's originally double of that side, because this side used to be twice bigger, and it used to be exactly equal to the other side. And the only other side that survived this whole thing that I just did is this side. So it must be the double of whatever I choose here. If I choose here 2, I will have to make here 4, right? So in that sort of things you choose, like you give it the beginning, but then because of the structure, you may have to follow the structure, right? Like, okay, if I choose here 5, I can choose it. I can choose whatever the hell I want here. Of course, I can't choose -5 because that would make sense, but technically I can choose. What is true, no matter what you choose here, is that this guy will be twice bigger. You could have started here, you could have said I choose this to be a 2, then this will have to be 1. Or you could have chosen this to be 1, and this would have been 1/2. But these numbers are not best, so I'm going to choose this to be 1, then I'll have to make 2 here, and then I will have to use Pythagorean Theorem to find the h, and then I'll have all my 3 sides. And the moment I have all my 3 sides, I have sine, I can write down sine, cosine, tangent, cotangent, all of them for any one of these angles, 30 or 60. That's why it's a special triangle. So eventually, this side, h, ends up becoming equal to square root 3 of whatever I chose here. So even if it was x, and this would have to be 2x, the h would have to become square root 3 version of x, like a little bit more than 1.5, 1.7 of x. This will always be true because Pythagorean theorem is not just a statement about somebody. It's a statement about any right triangle. It says that in any right triangle, the lengthiest side, which we call hypotenuse, its square will always be equal to the sum of the squares of other two guys. Because this is also always true, right, the theorem, its truth is derived from previous axioms. And axioms are true by definition. They can't change in time or in space. Eternal truth. This ends up making h squared. If you isolate everything, you will have, right, 4x squared minus x squared, and then you will have h squared equal to 3x squared. Ah, that looks like this guy. And then you take the square root of h squared, and you take the square root of the whole thing, right? You take the square root of both sides, and then you arrive at square root 3 times the square root of x squared, but that's the same thing as square root 3 times just x. Hallelujah. So now, you justify this. We justified to ourselves that this must be square root 3. Then that means that I can now forget about x's. I can just go with 1 and 2 times 1, right, instead of x. X was to show that it doesn't matter what you choose as an x. It doesn't matter what your starting point is. This guy will always be double of that smaller side, if you start there. Anytime you're facing 30-degree angle in a right triangular situation, your length will always be half the length of the hypotenuse. And the other side will always be square root 3 times version of that length that you are. So this relationship is eternal. Therefore, it's not a big deal for anybody then say, well, you know what, that means that I know the sine, the cosine, and anything else, right, of these angles. This means that I know, therefore, that the sine of 30, for example, is 1/2, 1 divided by 2. Because their ratios will never change. No matter what you put here, 2, 4, you'll always get 1/2. That's what I just said, right? It will be always half. Everything that I said in English actually can be written like this, in 2 symbols. Cosine, cosine would be, if I said cosine of 30, I'm talking about the ratio of this, the unknown height to the hypotenuse. Well, it will always be square root 3/2. Always, forever. And then, obviously combining these two, you can say, well, I know that tangent is defined to be the ratio between sine and cosine of that angle that I'm interested in. And that leaves me with no choice as taking 1/2 and dividing it by square root 3/2. That eventually gives me no 2's at the end, and only 1 over square root 3. Oh, so that's also eternally true. Yes.